Good evening, everyone.
Good evening, ma'am.
I haven't explained anything yet. So, have you guys started week 6 lectures?
No, ma'am, I didn't.
No. Okay. So today I'll just go through some theory based on week 6. So it will help you to understand lectures more effectively.
Ma'am, I'm audible to you.
Yes.
Hello, ma'am. Ma'am, today quiz one result has announced, and
Okay.
I got 7 marks in maths, and I'm pretty sure that I almost did a correct 12 question right. I don't know how I got 7 marks only. Uh, what to do now? Even the answer transcript is released. I don't understand. They just put the code of the question number and answer, and I don't have a paper to cross check that thing, and not the recorded video of the previous lectures, so as I can go through them and check what I did wrong. So to whom I got I get connect, and to whom I tell my like what I do now, what steps I need to.
Uh,
eh,
okay.
I
So
don't
you just
understand what.
put your email ID in the chat box.
Okay.
Am I audible clearly?
Yes, ma'am. Yes, ma'am.
Actually, I also don't know what you should do, but you put your email ID and your name in the chat box. I will ask our team member that what what is the best possible thing you can do now. Okay,
Okay, ma'am.
so just
So,
give me your email ID.
do I need to write my full name or just a name?
Just write full name. So
Also, you can write and support them.
what?
I already sent the mail to them, but they right now they just take 2 to 3 days uh, to get reply.
Okay, so don't worry. Just put your email ID and your full name. I will ask someone else in the team that what you can do, and I'll tell you in the next session. Okay, so you will
Okay,
attend next session. Whoever will take the next session, he or she will uh, tell you what you should do. Okay.
okay, ma'am. Ma'am, one thing happened in this exam center is that I just rechecking my paper, and at that time, uh, uh, after just it completely what we say in English.
You can
तो
say in Hindi if you.
या हम 2 आवर पूरे हो चुके थे, और मैंने
हाँ.
सबमिट बटन प्रेस नहीं किया था,
Okay.
बट मैसेज पॉपअप हुआ था कि सबमिट हो चुका है।
Okay.
ये इतना हुआ था, अदरवाइज आई नो कि मैंने सभी क्वेश्चंस के आंसर दिए हैं, सभी चीजें की है मैंने। सिर्फ मैंने ऑलमोस्ट 3 क्वेश्चंस के, आई थिंक 3 क्वेश्चंस मैंने अटेम्प्ट नहीं किए थे, वो जो
हम्म.
न्यूमेरिकल बेस्ड थे, बट
हम्म.
मैंने सभी के आंसर्स दिए हैं। इवन आई एम प्रिटी श्योर कि उसमें से 10 11 to 12 क्वेश्चंस आर राइट।
Okay, I will tell this thing also to the team that what should you do now. Okay.
कुछ समझ में नहीं आ रहा है।
नहीं नहीं, कोई बात नहीं है ना, चिंता की कोई बात नहीं है, हम लोग बात करेंगे इस बारे में। अगर आपने किए हैं तो आपका क्विज हो जाएगा, ऐसा नहीं है। Okay.
एंड वन मोर थिंग आई शायद लेटेस्ट अपडेट में सभी के पास आई गेस ये अपडेट आती है कि
Hmm.
प्लैग माल प्रैक्टिसिंग द असाइनमेंट्स और एग्जाम्स में भी सबके पास आया होगा, आई डोंट नो, बट ये
हाँ।
मैसेज पॉप अप हुआ तो मुझे समझ में नहीं आ रहा कि ये सबके लिए है या मेरे लिए है या किसके लिए, क्योंकि ऐसा तो मैंने कुछ किया नहीं ना
नहीं नहीं,
एग्जामिनेशन
ये
हॉल में।
वार्निंग सभी के लिए होता है। हम लोग
ओके।
क्विज से पहले सभी को ये चीज बताते हैं कि अगर कोई आई
हाँ
मीन चीट
हाँ।
करने के मोटिव से आता है तो सो he or she should know the what are the consequences will happen after that. Okay, so
ओके।
it's not for particular you, I think so.
ओके,
But
क्योंकि लास्ट टाइम जब मैंने ज्वाइन किया था इन दी सितंबर सेशन, तब मुझे पता है कि मेरे पास ऐसा कोई अपडेट उस टाइम पे नहीं आया था, बट अभी इस सेशन में काफ़ी कुछ चेंज हुआ है। वो मैं मुझे लग रहा है कि लोग लाइक पहले से जो लाइव सेशंस और जो रिकॉर्डेड सेशंस होते थे वो अब ज़्यादा अपडेट होने लग गए हैं टाइम टू टाइम, पहले नहीं हो रहे थे। लाइक सो मेनी चेंजेस आई नोटिस, बट ये नहीं पता था, इसीलिए मैंने सोचा एक बार मैं कंफर्म कर लूँ कि ऐसा कुछ है या उसकी वजह से मार्क्स कटे या पता नहीं, मुझे नहीं पता क्योंकि मैंने ऐसा कुछ किया नहीं है।
नहीं नहीं, कोई बात नहीं है। अगर आपने पेपर अच्छे से दिया है तो हम इस बारे में आराम से बात कर लेंगे। आप मेरे को अपना ईमेल आईडी और नाम बता दो। मैं
यस
मेरे जो
मैम।
भी सीनियर है या टीम मेंबर है मैं उनसे बात करके आपको अपडेट देती हूँ नेक्स्ट सेशन। ओके।
ओके ओके मैम।
So, shall we start now? I mean, most of the people have joined here.
Yes, ma'am.
Yes, ma'am.
So, you have done all the practice assignment question of week 5, and you have also discussed the solve with us session on week 5, right?
Yes, ma'am. Week 5 we are done almost.
Okay, fine. So, we'll start with week 6 now. Okay. So, in week 6, what we are doing that you already know what do you mean by exponential function, right? Exponential function a to the power x you have already studied. So now what is our motive that in so many practical areas it happened that you have to solve this type of equation that a to the power x plus cx plus something is equals to 0. For example, in particular case from the next session, 3 to the power minus x plus 2 is equals to 0, or 3 to the power minus x minus 2 is equals to 0. In the last section, we have noticed that this equation has a solution, but we don't know how to compute it. Okay. So somehow we got the intention that if we find an x such that this is true, then we know that that x will be a solution for our this expression or equation, right? So what does logarithm function do? Logarithm function just inverse of this function. Okay. Okay, Karishma, I will note your roll number and email ID. Okay. So now here the question rise that if your fx is equals to a to the power x, then we know what is the domain of fx. What is the domain of a to the power x?
Real number.
Correct. The whole real line. And what is the range?
0 to infinity.
Yeah, correct. Open interval 0 to infinity. Now, if we define our f from, or if we are defining a to the power x, which has domain real number, and it goes to 0 to infinity. So we notice that our a to the power x is reversible, right? Because if a to the power x1 is equals to a to the power x2, then we can easily say that x1 is equals to x2, correct?
Yes, ma'am.
Yeah, correct.
Yeah. And if I will take some y belongs to this 0 to infinity, then we know that our a to the power x is also onto, right?
Ma'am,
That's why we are saying
how do we know a to the power x is reversible?
by this thing.
Sorry, ma'am, can you start it from the very first?
Okay. So what I'm saying that in week 6, what we are doing, we are going from exponential function to logarithm function. Now, what is the motivation behind logarithm function? So it is just nothing but the inverse of exponential function. Now we first have to understand why the inverse of exponential function exists. Then only we can talk about the inverse of it, right?
Right,
If it does not exist, then there is no point of talking something, right?
right,
So that's why I'm saying that we know that our exponential function has domain R and range open interval 0 to infinity. And we also know that our exponential function is reversible, because if you take that one expression I have told last time, that f of x1 is equals to f of x2, if it implies x1 is equals to x2, then you can say that your function is reversible, right?
Right. Okay. Okay.
right.
Yeah.
So from
Ma'am,
this thing, yes,
ma'am, if the function is a polynomial, cubic polynomial,
yeah.
or the fourth degree polynomial, then how to check this condition? F of x1
Uh,
is equal to f of x2.
okay, we will get
That
back
would
that
be very
later.
difficult.
Okay, I will tell you in the last of the section. Okay, so just
Okay.
complete one part. Okay, so this thing you understand that from this condition we get that our exponential function is reversible, correct?
Right.
Yeah, and we also know that our exponential function is onto, because its range is open interval 0, 1. So you can easily check that if you take any y, we can correspond to an x such a way that a to the power x is equals to y, right? So it is also onto. So that means our exponential function a to the power x is inversible, or you can say bijective. So
Right.
that means we can talk about inverse of this function, right? So that's why we'll define. So we'll define logarithm in such a way that log of x base a is equals to y. This happen if and only if a to the power x is equals to y. This is the way of defining log. But one thing I should mention before that if you take f of x is equals to log of x base a, then here some restriction on a and x will happen, that your a should be greater than 0 and a should not equals to 1, because same condition we apply here also, right? A is not equals to 0 and a should be, sorry, a is not equals to 1 and a should be greater than 0, right? Same condition we apply on exponential, same condition we are taking for defining the log, defining the inverse of exponential function. Okay.
Okay.
So if we define f of x is equals to log base a of x, where we are taking that a should be greater than 0 and a is not a should be strictly greater than 0 and a should not equals to 1. But here what happened? Our exponential function a to the power x is from real number to open interval 0 to infinity. So if I want to define the inverse of this function, that function should be from open interval 0 to infinity to r, right? Right?
Yeah, right.
Then only it is possible, because we know that if f has domain a to b, then f inverse will be from b to a, right? So in
Yeah.
same way,
Yes.
our exponential function is defining from real number to open interval 0 to infinity. So if I want to define the inverse of exponential function, it should be from open interval 0 infinity to real number. Okay, so that's why we also take the restriction on x, because x is a domain, x is a point of domain, that our x should belongs to open interval 0 to infinity. So at the end we get this structure on our logarithmic function. That logarithmic function is nothing but a function which is defined in this way, that log of x base a, this is sounds like this, that log of x, this is called base. Okay, so the restriction on the base is our a should strictly greater than 0 and our a should not equals to 1, and the restriction on x is x belongs to open interval 0 to infinity. So if we define our log in this way, then we get a relation that log of x base a is equals to y. This happen if and only if a to the power x is equals to y. Okay. So any doubt on this thing?
मैम ये both way
This is how we
implication थोड़ा
define the
सा
log. That is the
मैम ये both way implication please
this one.
check this again. Yeah, the last
Okay, so you know that if
line.
f has inverse, f inverse. Okay. Yeah.
Yeah.
Right. So if f
Ma'am,
has
ये
inverse,
both
f
way
inverse,
implication
then
you have
f
write the
inverse. Yeah, you can write in both way because this function is inverse of this function, right? So you can also say that this function is also an inverse of this function in this way, right? F inverse is nothing but f. So that's why this both way implication will take care of it. Okay.
oh,
So
No,
at the end,
can you give us some time to observe that properly?
yeah.
Yeah. So here, log x base a is equal to y, if and only if a power x is equal to y. I mean, does
Yeah.
it mean that log x to the base a is equal to a power x? No.
Wait.
no, it is just notation, I think.
Yeah, just a notation.
Just is yeah.
It's just a
It
notation.
is
We are
just
defining
showing
it this way.
it is just
Huh.
showing the
The connectivity between two functions. For example, you define a to the power x. It has certain meanings that we are multiplying a some x time. Is
So,
rough meaning is there, right?
yes,
But
yeah.
here we are taking that log is something which define the inverse of this function. We don't know what does this log stand for. Actually, log of base a of x is equals to y. It defined in this way that you can say that log base 2 of 5 is equals to 6. This happen only if you can say that 2 to the power 5 is equals to 6.
yeah.
2 to the power 5
Okay,
This is
so
the
it's just a
actual
notation,
meaning.
nothing else.
I mean, like, what do we
No,
understand
ma'am.
from these two? I mean, it's just a good.
I'm just telling you that what is the motivation behind defining the log. It is not just coming something from heaven or like we are just
Okay.
we know that this function is inversible, right? This function is bijective. So we want something which can define its inverse. So we are saying that that something function is nothing but log of a base x and the output will give is y.
Okay. Y will be a power.
Yeah, ma'am. But if we convert it exponent,
Okay,
then
sorry.
it become the a to the
Yeah,
power y equals to x.
Yeah. I missed it.
Yeah.
What is it?
That a to the power y is
A to
equals to
the
x.
power y
Then only that's why
equals
you are
to
getting
x.
confused, right? Because here
Then
output is y, so
yeah.
input should here y, and here output is
Yeah.
x, so that's why input should here x. Okay.
Oh, so the
So
whole
now it
thing.
is clear. What?
Can you just represent the earlier equation again fresh?
Yeah. I'll
This is
just tell. Okay. So what happened? Log is defined in this way that log of base a of x, you say that it is equals to y if and only if a to the power y is equals to x. So that means this log of base a of x is well defined only when sorry.
okay. So it was never a power x is equal to y. It was a power y is equal to
A
x.
to the power y is equals to x.
Exactly.
Yeah.
Okay.
That's
Now, okay. I mean,
now it's
earlier
clear,
was,
right?
yeah.
I also
I
missed that thing.
got it.
Fine. So whenever you see that the log of a base x is equals to y, you just remember these two conditions that your base should be strictly greater than 0. It should not equals to 1. And your x should belongs to open interval 0 to infinity. Okay. So these are the three conditions which will help you to define log that whether it is well defined or not. Okay. And this expression that log base a of x is equals to y if and only if you can remember in this way. I also got confused that a to the power y is equals to x. Fine. Okay.
Yeah.
Got it.
Ma'am, can A be negative?
No, a cannot be
Value?
negative because in exponential function what you have say that a to the power x is well defined only when your a is strictly greater than 0. We cannot define -1 to the power 1/2 or something, right?
Okay.
So that's why this condition is coming from exponential function. The main point is that. Okay.
Now, when you restrict x values to be from 0 to infinity.
Yeah, we are restricting it to be from 0 to infinity because what we want our log to be the inverse of this function, and this function has range open interval 0 to infinity.
Okay, but
That's
when we
why we are
say,
restricting.
but generally when we say a power x, x
Yeah.
will have, it can also
Yeah.
take negative values.
Yeah, but
Yeah.
it is inverse now, so you can assume that whatever range space it is, it will become domain here, right?
Okay, okay,
Range of this will become domain here because inverse function has that property. If f,
okay.
if d is a
So,
domain of f, then
okay,
d
so
will be the range of f inverse.
we are restricting x values to be between 0 to infinity
Yeah,
for
correct.
log, for log, only for log.
Yeah, for log, just for
Okay.
log. So
All
that
right.
means our log is log base a. Actually, this base will fixed first, as in exponential function we talk about 3 to the power x. So first we will fix a, right? So
Okay.
in log also, first we will fix our base, that it is a function which has domain 0 to infinity, right?
Okay.
And it has range the whole real line. So this is the domain of log, and
Okay.
this will be the range of log.
Okay.
Now it is clear?
Yeah, understood.
Sorry, I missed this point. Now, when we define a function, we need certain property that it is reversible or not. So what you guys think, it is reversible or not?
Sorry, ma'am, what was the question?
Yeah, it is reversible.
I'm saying that we are defining a function f to be log base a, which is from domain this to domain this, which is defined in this way, which is defined in this particular, with the help of this particular expression, right? Okay. So I'm saying that whenever you have a function, you always ask a natural question that it is reversible or not. So I'm asking you that this log function is reversible or not.
Yes, ma'am.
It should be reversible because we have the other way around, right? A to
Yeah,
the power
correct.
of a equals
So
to
this
x means
function is also reversible as well as onto. Why? Because this is inverse of some function.
right.
So whenever you get an inverse of some function, it will always be reversible and onto. Yeah, correct. So that's why. So now you get what is the log function, how it will define, what is the domain, range, and as well as it is reversible and onto. And what is the inverse of log base a?
It's again an exponent.
A to
Exponential
the power of
Exponential
y
function.
equals to x.
It is again a to the power x. So I think you have studied log in your 10+2 level or something.
Yeah.
Fine.
No, ma'am.
Okay,
Can
don't
you
worry.
just,
Ma'am,
can you
a
just
to
show
the
it
power
again,
of
screen?
y, right, ma'am?
Just copy that down. Yeah, I'll just copy it down. Yeah.
Got it?
Ma'am, here
A to the
a to the
power.
power of y, right?
Yeah, a to the power y is equals to. Okay. Yeah, a to the power. Let's take it.
Okay.
Fine.
And you confused.
Okay, I confused. Yeah, actually, I already
No,
confused.
no,
I'll
it's
write in
clear, ma'am.
clear way
It's
here
clear now.
that log base a of x is well defined
A
now
power y
last
equal to then
when a is strictly greater than 0, a is not equals to 1, and your x should belongs to open interval 0 to infinity. And there is a relation that how it defined that log base a of x is equals to y if and only if in something like this a to the power y is equals to x. Just remember this t or something, that a to the power y is equals to x. Okay, this thing you
yeah,
got, right?
then if we take log on both sides for this a power y is equal to x, we'll get this one.
Sorry, what?
If we take log on both sides, so for this
Yeah, that's why I'm
equation a
taking now
power y
that
is
when
equal to
you
x,
take
we'll
log
get
on both sides, what will happen if in this case, if you take log base a of a to the power y is equals to log base a of x. So what will happen, this log and this exponential, they are inverse of each other, so it will become identity. So that means this is equals to y, something like that you can remember. Okay, but there is a property, we'll come to properties later. But first you just take care of this condition, that first thing is log is well defined when this condition will happen. And how it is defining, we are defining log in this fashion. Sometimes every function need not to be have explicit expressions as like x cube plus 2x plus 3 or something like that. Sometimes we also define functions with the help of these types of relation, if and only. Okay. Got it?
So as far as exponents and log are concerned, they are irreversible.
Yeah,
Always.
always.
Okay.
Fine. So we got the domain,
Oh,
range,
sorry, I said irreversible. They are reversible.
no, irreversible, no, reversible. I mean
Yeah.
bijective.
Okay.
Both are bijective.
Okay.
Okay. So now we'll discuss some of the properties of log. Maybe you guys will familiar, or we can discuss the graph also. So how does the graph of log will look like? Okay. Graph of log base a of x. How it look like? Okay. So can anyone tell how it look like? Because we have some intention that log base a of b is nothing but the inverse of a to the power x. So you know how do you get the graph of f inverse from the graph of f? Anyone know?
We draw a line y equals to x, and it would be
Yeah,
symmetric across it.
correct. So what will happen? That we'll draw this line y is equals to x, and we just act this line to be a mirror. And whatever graph we will get, that will be the graph of f inverse. For here, what we have graph of a to the power x. Okay, so we have graph of a to the power x in two scenarios, right? So when our a is between 0 to 1, so suppose if 0 is strictly less than a is strictly less than 1, then what is the graph of a to the power x? It is increasing or decreasing?
Decreasing.
Decreasing, right? So if you want to image this graph with respect to this line, so what will happen? This whole part will look like something like this, right?
Yeah, right.
But what happened here? This part is above this zero line, right? So the image part will also be parallel to this y x is equals to 0 line. It will be the asymptote of this thing. Okay, so this will be the graph of log of base a of x. Okay, so I'll draw it here. So if 0 is less than a is less than 1, then the graph of log of a will look like this. Yeah, sorry. This is exponential function. Will look like this, decreasing.
Yeah, this one.
Okay. And when a is greater than 1, we know that the graph of exponential is increasing. So its inverse function graph should be decreasing. Wait, sorry, should be this way. This will be the graph of log base a of x when a is strictly greater than 1. And this will be the graph of log base a of x when our a is between 0 to 1. Okay. So this thing is fine for everyone. Any doubt?
No, give us some
No.
time to really digest this.
Ma'am, can you draw the graph of the exponent just below these ones for both the cases?
So exponential graph will be what behave like this thing, right? In this case, right?
Right.
This is a graph of a to the power x. If you draw a line here, what will happen? This part will reflect here, and this part will reflect. This part will reflect here, right?
Okay.
As a mirror, you can imagine like a mirror, right?
Yeah, right.
It is difficult to imagine when you draw this vertical line, but this is just for your motivation. Here it is very clear, right? Because here our graph won't cut the line y is equals to x. So it is just, this is a graph of e to the power x, and the reflection will be the graph of log base a of x, correct?
Right. This one is
Here
easy
it is
to
more
understand.
clear, but
Right.
here since it is cutting this line, so that's why the image will, how it look like will get confused. But you can assume here, right? This is a line y is equals to x. Now you got the graph of what is the graph of log base a of x, correct?
Yeah.
So in case of log, you should remember that how it defines, why it defines, and what is the graph of your log. Okay. So now using the graph, we can define what is the end behavior of this graph, right? So what will be limit extending to infinity, log base a of x in this case, and similarly limit x goes to minus infinity of log base a of x. Okay. Just think what it should be using the graph. Okay. And answer in the chat box also. It's not that you should always switch to minus infinity log base a of x. Because I'll write an option so that you can answer it. A, B, C, D. Take time, see the graph, observe it, what you think what it should be, or just remember what is the end behavior exponential function and try to reverse it in some way.
Extend to infinity, it goes negative minus infinity.
You can answer in chat box, okay, so that everyone should think. Everyone should have to answer, okay. If it is correct or not, doesn't matter. Just think and answer.
Ma'am,
Yes.
what is the question?
So question is, with the help of graph, what do you think about these limits? Limit x goes to infinity, minus infinity, in this end behavior of the graph in these two situations, when a is between 0 to 1 and a is strictly greater than 1.
Oh,
Ma'am, over
Yes.
here, when you're drawing this graph, it is a to the power of y again, right? It's
Yeah,
not a
yeah,
to
it
the
is
power.
again a to the power y.
Okay.
It's not x. It's habitual of writing x. It's again e to the power y, right? The main point is the graph of log is just the reflection of exponential graph with respect to this line, y is equals to x. We are
Now
doing
in the
nothing.
first, see, you said the b limit extends to minus infinity log x of, I mean, to the base a, but
Yeah.
there I don't see x to the limit of minus infinity, isn't it? Like,
Yeah, that's why I'm telling that you see the graph. What do you think? It will exist, not does not exist, or something.
oh, okay, all right,
Define, not define.
ma'am, I
okay.
Can
had
go
the
to
same
minus
doubt.
infinity.
Ma'am, actually, I have the same doubt because if I reverse it, you told reverse the exponential function. So for
Yes.
that, we will get the value. But if I'm looking the
Yeah.
graph, there is no negative infinity for the B option.
Yeah. So that's why exponential function has range 0 to infinity, right? So our
Hmm.
log should define from open interval 0 to infinity to r. We are taking inverse of something. You are getting point of inverse. If suppose you have two set a and b and your function f is going from a to b, then your inverse should come from b to a, right? Right
Right,
now.
ma'am. Mm-hmm.
So here we are via exponential, we are going r to open interval 0 to infinity, e to the power y. And from 0 to infinity to r, we are coming by log base a of x, right? So that's the point here, that a log is never defined in this axis, the negative real axis. You cannot define it. So the question reduces here. So since we cannot go to minus infinity, right? So
Yes,
at minus infinity, we don't know what will happen. So we can just tell it when x goes to, but we can go to 0, right? Because our domain will have open 0. So what happen if we go to 0 in case of minus infinity? So here also we cannot go to minus infinity. We'll go to 0. Okay. Now you give the answer. What is the answer? Okay. You got my point, right? Why we are not going to minus infinity? Because it is not defined at there. Right?
yes, ma'am.
So that's why now you'll say what is the limit when x goes to infinity? X goes to 0 in this way, and in this case and in this case, both of the cases. Then we will discuss some properties of log. I can read this. Okay. So I think now it is clear. So what will be the answer for A? As x goes to infinity, this is decreasing, right?
Minus infinity.
Minus
Minus
infinity.
infinity.
Minus
Minus infinity.
And for this, it will be plus infinity, right?
Infinity.
Here it is just reverse. So
Right.
as x goes to
Infinity and
infinity,
minus.
our function is increasing. So it is plus infinity, and as x goes to 0, it is decreasing. So it will be 0. Sorry, minus infinity.
Minus infinity.
Ma'am, could you please repeat that? I couldn't follow that actually.
Which part? This
Ma'am,
limit part?
yes, ma'am, please.
Actually, what happened now? Here our domain is just the positive real axis. So we cannot talk anything on the negative real axis. So that's why I'm saying that x goes to minus infinity. This limit is useless for us, because as we are not defining the function in so much part. I mean, we are not able to define it on the -1. How can we reach minus infinity, right?
Yes, ma'am.
So that's why we are not talking about this limit, that limit x goes to minus infinity. But we can talk about x goes to 0, right? We have open interval 0 to infinity. So this 0 somehow behave as minus infinity in this case, right? But you should not get this thing like that. Okay, so we can talk about limit x goes to 0 of this function, right?
Yes, ma'am.
That's why I'm saying. So now here you can get some intention that limit is always not, it is not the case that limit is always defined for any arbitrary function, right? So here we observe that limit x goes to minus infinity, we cannot think anything. Okay. Now this
Your voice is
behavior is clear
breaking.
once again. So now what? Sorry, my voice is breaking again.
Now it's clear.
Now we will go with, okay, so I will give you an example. You have to draw the graph using the scaling method, which I have taught you in the last session. Okay, so draw the graph of f of x is equals to log base. Here don't don't bother about the numbers, just give me the rough graph how it should look like. Okay, 1 by 4 plus 1 x plus 3. Just try to draw this graph roughly. what you can get using the scaling method. Scaling or shifting method, which we have discussed in last session. Okay. So I'll give you 3 minutes, then I will discuss this. Correct. Okay. So everyone got this graph? Should I give more time? Do you want any? So we'll discuss this. Okay. So what is the main core function in this graph? Am I audible?
Yes, ma'am.
Yeah.
So what is the
So
core function in this? Yes.
first of all, A is between 0 and 1.
Yeah, correct. Your A is 1/4. So that means A is between 0 and 1. And the core function is just log base A of x. So we know that when A is between 0 to 1, our function will look something like this. Right?
Right.
Then what happened? We are adding 1 in the x x coordinate, right? So that means our graph will shift left to 1 unit, right?
Yeah.
and we are adding 3 into our y coordinate. So that means our graph will shift to 3 units upward. Okay, so I will
Yes. So that means our function have the domain -1 to infinity.
yeah, we can discover that thing using the graph, also using the expression. So what will happen, this is our original graph. This is the graph we can easily draw of log base 1/4 of x, right? So now what we are doing, we are adding 1 unit in our x. So what will happen, our graph will shift to 1 unit in the left direction, right? And what we are doing, we are adding 3 in your y coordinate. So that means our graph will shift to 3 units upward. So this is how the graph will look. Something like this. And it will intersect at the point 3 and 1. So this will be your y-intercept. And from here, you can get that your range will still from 0 to infinity, because our graph is going upward and it will reach to minus infinity. But our domain now, you can observe that our domain will also getting some point from the negative real axis, right? This is because of this shift x plus 1. Okay.
Yeah.
Got it?
Yeah, got it.
Fine. So this is the graph of this function. Now I'll discuss some basic property of, yes.
No, can you just describe how you actually drew the graph?
Okay, so what will happen? This is our graph, right? This is the graph of log base 1/4 of x, right? Now what I'll do, I'll add 1 unit in the x coordinate. So so now
Okay.
I have to draw the graph of x plus 1, right? So what will happen? This graph will move 1 unit.
So for
Towards
both
left.
exponential function as well as logarithmic function, it will only move
Yeah.
to the left.
Yeah, every function will move left.
Even
If
for
you're adding,
hyperbola, even for parabolas, everything.
yeah,
Okay.
everything.
Everything.
Doesn't matter whatever function you have described. If you are doing scaling, scaling is true for every graph, every
All
function.
right. All right. All right.
You don't have to reverse this in this way.
Okay. I mean, that is where I got mixed up.
Yeah.
Okay.
Okay. Fine.
Okay.
Okay, ma'am, what will be the range of this function fx?
Range. Now we are shifting its 3 units upward, right? So, but still, it will
Yeah, right.
actually. What happen as we in this case, as we goes to limit, limit x goes to infinity, log of 1/4 of x, this will goes to infinity, right? Because it is a decreasing function. So doesn't matter, you will shift 3 units upward, it will still go to minus infinity, right?
Oh, okay.
So
Okay.
yeah, so it will still go to minus infinity. It doesn't
So
matter.
the range will be okay.
Yeah, the range is still the whole
But
real
but
line.
but
But what
as
I'm saying,
x
when we
goes
shift
to zero,
this,
but but as x goes to 0, it will go to -1.
yeah, because our graph is shifting 1 unit this way, right?
Right.
So now you can able to define your graph for this will be your asymptote now. X is equals to -1. So you can define this function in the interval of -1 to infinity. There are some question based on the domain of log. So whenever you want to find the domain of some log function, now what you have to do, you have to use the condition which we have applied on x. What I'm saying, that when we define log base of x, and I always say
Ma'am, you're not audible.
We lost you, ma'am.
Hello.
Hello?
Yeah, I think ma'am got disconnected.
We can't hear, ma'am.
Yes,
Yes, we lost her.
Got disconnected.
Am I audible now?
yes, ma'am.
Yeah,
Yes,
ma'am.
ma'am.
Sorry, actually, internet issue. Okay, now I can't share my screen. Just wait for a second. Just give me 5 minutes. I'll share my screen once they are.
Okay, ma'am.
So till now, you can think about what is the value of log base a of 1, what it should be, using the fact that exponential and logarithm are inverse of each other. Just think about it. What is the value of
Ma'am, x base 1.
Log base a 1. Log of base a 1. What it should be for any a.
Ma'am, 0. Because a power
Think
0 is
once
equal to
again.
1.
Think once again. Yeah, you are going in the right direction, but your answer is not correct.
Ma'am, can you write down because it will be clear
Why, ma'am?
Yeah,
to
enter
understand?
in the chat box. Log base a of x is equals to 1. I mean, not x is equals to 1. Log base a of x, a of 1. You got it? Yeah. So what I'm saying, what do you think about log base a of 1 should be for any
Equal to y, ma'am.
0.
No. Think again once. You're going in the right, yeah, correct, 0, sorry. You're going in the right direction. You said 0 or 1 last time. You said 0, right?
No, ma'am, 0, 0.
Yes. So it is 0.
Yeah,
Why it is
0.
0? Because you know that a to the power 0 is always 1.
Yeah.
So from there, what is the value?
Okay.
Here output is 1 and here input is 1, right? So they are reverse of each other. So log base a of 1 is always 0 for any. Okay.
Ma'am,
Yes.
ma'am, I have a question in the previous question.
Yeah, from week 5.
No, ma'am, that you were discussing a log a 1 by 4 something x plus 1. If it was x
This
minus, yes, ma'am. If it was x
okay.
minus 1, then ma'am,
Okay. So here what I'm saying that our we know that our log function is defined when our x is strictly greater than 0, right?
yes,
Right.
ma'am.
So in this case, in place of x, what we have? We have x plus 1. So if you put x is equals to minus 1 by 2, so still x plus 1 will be minus 1 by 2 plus 1. That means 1 by 2. That means still it is strictly greater than 0. So that means x is equals to minus 1 by 2. Still for x is equals to minus 1 by 2, this log is well defined, right? You
No,
got this fact?
my question is x minus 1. If it was x minus 1, then
This question.
ma'am, same question you have written x plus 1. If
Okay,
it
okay.
was
In the problem sheet, you have x minus 1. Yeah, so what happened when you want to think about that when x minus 1 is strictly greater than 0. So this is happen when an x is strictly greater than 0. So in that case, the log base a of this, it will well defined. So that means it will have domain when 1 to infinity, right? In place of minus 1 to infinity in our previous case. Okay, got it?
It should be, ma'am, greater than 1 now. You have written greater than 0.
Yeah, greater than 1.
Yes, ma'am, got it. Thank you.
Okay, so everyone fine with this property that log base a of 1 is equals to 0 for all a. Okay,
Yeah.
so we'll go to next property. So these property you have seen already, I guess, that log base a. Okay. Mn is equals to, what is it?
Log m base a plus log n base a.
Log base a of n. Second, similar for division, that m by n is equals to log base a of m minus log base a of n, right? So these property you can prove easily with the help of this relation, right? Log base a of x, this is same is equals to y. This is if and only if a to the power y is equals to x. Okay, just use this relation, you can easily get these two things. Okay, just first use this relation here and use the property of exponential. I'll prove one. Okay, so if I have log base a of m n, so what it can be in the suppose this is equals to some y1. So this will implies that a to the power y1 is equals to mn, right?
Yeah.
and log base a of m is equals to y2. This will implies that a to the power y2 is equals to n m, right? And log base a of n is equals to y3. So this will implies a to the power y3 is equals to n. But what we have, mn is equals to a to the power y1. So this will implies a to the power y1 is equals to a to the power y2 into a to the power y3, right? Just putting this m and n values in this equation. Got it?
Yes, sir.
Right?
Yes, ma'am. Except the last one should be a, right? A to the power
Yeah.
of y3.
So this will implies a to the power y1 is equals to a to the power. Now we have a property of exponential that a to the power y2 into a to the power y3 will be a to the power y2 plus y3, right? So this will implies your y1 is equals to y2 plus y3. Now what is the value of y1? So y1 is log base m, log base a of mn. This is equals to log base a of m plus log base a of n, right? In the similar manner, you can prove all this property. It is just computation, nothing more than that. Okay. So these two properties are clear. High school properties. Now third one, that log base a of, this is trivial, right? 1 by n is equals to what it will be?
Minus log n base a.
Yeah, correct. Why? Because we apply the previous property, so it will become log base a of 1 minus log base a of n. But as we know, log base a of 1 is equals to 0. So this is nothing but minus of log base a of n. Okay. Now, using this property, you can also derive some more properties. That's using the above two properties, you can also derive this thing, that log base a of m to the power n. This is nothing but n times. Why it is n times? Because m to the power n is nothing but m into and so on into m, right? And here I am assuming that your n is belonging to natural number. Okay. Right?
Yeah.
So by
We
using
are adding
the
m times.
Right.
what? Sorry?
We are adding m times. We are adding log
Yes.
m base
Yeah,
a.
we are just adding n times log base a of m. So it is nothing but n times log base a of m. Okay. So this is the fourth property. Now, there is one crucial thing about log that
I
you
didn't
can
understand
see.
this, ma'am. What is this? M to the power of n? What did we do here?
We are just m to the power n. You can think this thing as m into m into m n times, right?
Oh, so n times you
And
multiply.
yeah,
N
and
times.
you can use the property 1, that multiplication rule, to distribute it, and then you add the whole thing n times. So it will become n times log base a of m. Okay.
Oh, yeah.
So this division rule can be similarly proven by this thing. Okay, just work it out. It is easy, nothing much. Okay. So remember these properties. Okay, mainly the multiplication and the division rule and this power. Now here we have proved that this can be this thing, you can assume that log base a of n to the power minus 1, right? Right?
Yeah.
So similar fashion, in the similar way, we have our next property, that log base a of m to the power minus n. This is nothing but minus n log base a of m. Where again n we are taking from natural number, any natural number. Okay. Fine. Now,
Yeah.
now what happened in log? In log, we usually define log base a of x. So that means we are first fixed our base. We are first fixed our base. What is the whatever the base we are talking about, and then we are defining the log. So there is one property of log that you can also change this base with some another base. Okay, so that's why I'm Okay, so let us suppose your 0 is less than a is less than 1, or a is strictly greater than 1, and you have some another b, 0 is less than b is less than 1, or b is strictly greater. Then log has this property that since we have domain x, so for x belongs to 0 to infinity, we have that log base a of x, this can be interpreted as log base b of x upon log base b of a. Okay, so in this way we can change our base from a to a to b, or b to, because first we have to know what is the base of b, and then we can change over, right? So this is called change of base from b to a or a to b, whatever you want. You can use this property to get your answer, right? So this property is clear, change of base.
Ma'am, could you
No,
please
ma'am.
repeat it?
I didn't follow.
Ma'am, this log x base b and log a base b becomes common logs. Right? They'll become like
They'll become what?
common logs, means log x base
uh,
becomes 10.
Yeah, so this property is important. Why I'm telling, I will get back to that. First, understand what does this property mean. So what we are doing, we want to change our base from a to b or b to a. You can go in either of the direction. Just replace a by b or b by a. That doesn't matter. First, you have to observe that if you have a base, so for base we have this condition, right? This is a condition for base for log. Yeah. Now I want to change my base to some another base. So whatever the other number will, that should have the same condition, right? So that's why I'm taking here that b is between 0 to 1 or b is strictly greater than. Now, this property tell us if you have log base a of x, this is same as log base b of x upon log base b of a. Now here log base b of a is also well defined, right?
But how do we know that this division is
Yeah,
same
yeah,
as?
I will prove it. I will prove this. Okay, so just go through proof. Okay. So using the same method, let us suppose log base, this is a. Okay, so log base a of x is equals to some y1, log base b of x is some y2, and you have log base b of a is some y3, right? Okay, so what can you say here? That a to the power y1 is equals to x. A to the power y1 is equals to x. Here you can say that b to the power y2 is equals to x. And here you can say that b to the power y3 is equals to a. Right? Right or not?
Yeah, right.
Right,
Now,
ma'am.
now just observe this this condition. That what can you say? Now, so we have b to the power y2 is equals to x, and we have these two things. Okay, so now what I'll do, so I will take b to the power y3 to the whole power y1. So what will happen then?
The powers will be get multiplied,
Yeah, the
like b
power
to the
will be
power
y3
y3 into
y1.
y1. Yeah, and then commutative, like a y1 inside and y3 outside.
Yeah. So this will b to the power y3 will become e to the power y1. So this will become x, right? This is what? This is a to the power y1. So here b to the power y3 is equals to a. So in place of a, I can write b to the power y3, right? So b to the power y3 to the power y1 is equals to x. So this will use us this
Yeah,
thing,
yeah. A
right?
whole will give, yeah.
Yeah. So from here, what can you say about? I
Ma'am,
mean, if I want to change that in the form of log, so what can you say? That log base what? Just pretend it to be some c to the power r is equals to s. Then what can you use the log thing? What will be the base? Base is always this thing, right?
Is A.
Ma'am, we are two rows above trying to understand right now. I don't know if
Okay,
everybody is there or not.
okay, fine. So
In
I'll just go
either way,
slow.
we can prove it. Like
Ma'am,
we can
could you
take.
repeat for that P y3 y1 is equal to x, ma'am?
Yeah, okay. I'll restart it again. Okay. So I think I go. So what we have to prove? We have to prove that log base A of x is equals to log base B of x upon log base B of A, right? So what I'll do, I will interpret each term using exponential because I know how to deal with exponentials, right? So log base A of x, this, if I'll suppose this to be y1, then what will happen? That a to the power y1 is equals to x, right? Similarly, log base b of x is equals to y2. If I'll think, it will be happen that b to the power y2 is equals to x. Okay,
Yes, ma'am.
correct? Similarly, log base b of a, if I'll assume y3, then this will happen that b to the power y3 is equals to a. Now here you observe that in these three equations, you have a here and you have a here. So what I'll do, I'll put the value of a in this equation. Okay, now it is more clear. So it will become b to the power y3, this is the value of a, to the power y1 is equals to x, right? Correct?
Yes, ma'am.
Now you got it? So it will
Yes,
just
ma'am.
nothing but b to the power y3, y1 is equals to x. Now, what I have to do, I have to convert it again some log form. So what will be the log form of this equation? It is log of base what? You know this thing, right? A to the
Base
power x
B.
is log base a of x, right?
Yeah.
So
Yeah.
base will be b, right?
B. Yeah.
And what is the value of here?
Y3, Y1. X.
X, right?
Yeah. Log
No,
X base B equals to
yeah,
Y3, Y1.
y3, y1, correct? Got it?
Yeah, correct. Yeah, correct.
Everyone?
Oh, ma'am.
Ma'am, one second, ma'am. 1 second.
Yeah. Just take your time.
Just absorb this. Log.
Ma'am, here it will become a power y, right?
A power, yeah, a is, but a is what? So a is nothing but b to the power y3, right? Your a is nothing but b
No,
to the power y3.
in the bracket you have given a power y implies it will
Yeah, a
become
to the power y1.
log x base a. Can you just scroll down?
Okay.
Down, ma'am, down.
Again down.
Ma'am, no, in the previous slide.
This one. What's your question? You can say.
This one, ma'am, a power y.
A power a. This is a, right? So a to the power
In the
y1 is equals
last
to
one,
this.
ma'am.
So
Last
it is
one.
b to the power y3 is equals to a, right?
Not
This,
that. No. Below
which
that,
one?
in bracket, you have written something.
This b to the power y3.
Oh no. In the last one, last. Can
You
you
scroll
scroll
down a
down?
little bit more, ma'am. Yeah.
Yeah,
This
here,
Okay.
thing.
ma'am.
Okay, fine. Why
A
you guys
power
always
y.
confused? You know this expression, na? That's why I'm telling.
That is what the conversion means, like exponent to logarithm and
Yeah,
logarithmic to
you know
exponent.
how to change
That is
it.
the definition of
That is the
conversion.
definition. That's why
Yeah,
I'm
that is
telling
the one.
that this is something a to the power y is equals to x. I want to get it
Yeah.
in the form of log base a of x is equals to y. So that's why I'm telling
Yeah.
if you have exponential expression this, then how you go to the log? That's why I'm asking. That's why I written
Yeah.
this. Just
Yeah.
hang in.
Yeah.
Okay.
No,
So
ma'am.
it
Over
is.
there the confusion was you wrote a to the power of x equals to that.
I got
To
it.
the,
What this? But this that I just write for intention that how you should go. Right now it is clear.
yes, got it.
Yeah.
So
Yeah.
far we
Yeah.
got it.
Ma'am,
So
here
this,
x is equal to y3, y1 or the whole is equal to y3, y1. It is whole now.
yeah, y3 to the
Yeah,
power
y3, y1 is, yeah, taking as a whole.
Yeah.
y3, y1. Sorry. Yeah, we are taking as a whole. I mean, this is the property of exponential, right? A to the power r to the power s is same as a to the power rs, right?
Yeah.
So I'm just using this property here.
No, ma'am, not for that. Actually, in the left hand side,
Yeah.
you wrote log x is equal to y3, y1. So I got
Yeah.
confused that x is equal to y3, y1. It is
Log base
actually
b.
it is actually log base b to the power x is equal to y3, y1 now.
Yeah, so that's why I'm writing,
Yeah,
no?
that's
Oh,
what
this is
written.
not. This is something else. You are interpreting this or something else. This is not I'm
Now
writing.
got it, ma'am. Got it, ma'am.
Yeah, this is the main expression I have got. This is for this a to the power y is equals to x. That's why I want to write this property. Right. Now it is clear? Till now it is clear?
No,
Yes,
Yeah.
ma'am.
ma'am. Still, that what is log a log x base a that is equal to a1 means a to the power of y1 is equal to x. That step I can understand. After that,
Okay.
how you derive that this
Same
whole
thing, same thing. Just b to the power y2 is equals to x, right? It is not always the case a, b, x will use. You can use any of them, right? It is not always fixed that a is something, b is something. A, b, we are just representing it. There are just symbols, right? It will change. So I'm just, in place of a, I'm taking b. In place of x, I'm taking x itself. In place of y1, here it is y2, right? So what will be the exponential form of this log? It is b to the power y2 of x, right? You know how to go from exponential form to the logarithmic form. In place of a, b, x, y, z, there could be anything. I mean, for example, if I will ask, what is the exponential form of this thing? What you will say? What is the exponential form of this thing? Even if it is not defined, just forget about that. I'm asking, what is the exponential form of this thing?
a to the power 4 to the power of 5.
Correct. 4 to the power 5 is equals to 18, right?
Oh yes.
Yeah, so same thing I'm doing here, but just in place of a, b, I mean, just in place of a, there are some other variables now.
But you
Okay.
said here you are proving no, ma'am.
Yeah, I'm proving this
How you
property
prove
that
it?
why
I can't understand.
sorry.
First left side LHS like the RHS. How did you derive at that time?
Okay. So now you got it. How did we come up with these three expressions?
Yes, ma'am.
Okay. So now in the next step, what I have did in this three expression, I have some intention. I got that here is an a and here is an a. So what I will do, I will put the value of a, which is b to the power y3, in this expression. So what it become, b to the power y3 to the whole power y1 is equals to x. Correct?
Yes, ma'am.
Right? And then we use the exponential property that it will become b to the power y3 y1 is equals to x. Now this is some exponential form. I want to go back to our logarithmic form. So what we'll do? So we'll take same thing, that this exponential form is same as this logarithmic form because it is log base b of x is equals to y3 y1. So this is what we get till now, right? So till this expression, everything is clear. Should I repeat again? We are proving this property that why it holds. It's a proof. Okay. Fine.
Yes, ma'am.
Yeah.
Able to
Now
write
I'll
that.
put back the what is the value of y3 and y1 and we are okay. So it is simply log base b of x is equals to what is the value of y3? So y3 value is this log base b of a into what is the value of y1? Y1 value is log base a
Log
of
x
x.
base a.
Yeah, log base a of x. So from here we can extract the terms which has base b. So what we'll get? So we get log base a of x is equals to this term will go in the denominator of this. So it will become log base b of x upon log base b of a. So this is our property. This is what we have to show. Okay. Fine.
Yeah, fine.
Now you got it, how it come, from where it come. It's just simple multiplication, that what you have to show and what you know. There's nothing. You just have to jump from exponential form to logarithmic form, and from logarithmic form to exponential form. The vice versa thing. Okay. So this is the final expression you got. Okay, fine. I'll
Yeah,
give an
fine.
example. So it will be more helpful that why it is important. Okay. Suppose I'll give you a statement or question that 1 upon log base 2 of pi plus 1 upon log base 6 of pi is strictly greater than 2. Tell me it is true or false. So what is your natural what is the first step you will do with this expression if you want to prove it, or if you want to think that it is true or false? What you will do?
Ma'am, this is log 2 of pi and log 6 of pi, is it?
Yeah, log base 6 of pi and log base 2 of pi.
We will change it the same basis.
Yeah, correct. But why we have to change? Because we always know that whatever property, observe here. Okay. Here, these 4 properties
Like first,
is
yeah,
defined
yeah,
on the
four.
same base. You observe this
Yes,
thing, right?
yeah,
So that means if I
yeah,
want
yeah,
to apply some above property, first I have to change it into the same base, right?
yeah, right.
So now here 6 is somehow look like 3 into 3 or 2 into 3, right? So I somehow get intention that okay, I can change it to base 2, right? Okay. So here
Yeah,
what I want to change this condition to base 2. So here our a will be 6, our b will be 2, right? So I want log base 6 of pi is equals to in the form of log base this. Okay, so first I will write the equation. So log base a of x, what it is? It is log base b of x upon log base b of a, right? So this will
yeah,
become now
right.
log, in place of a, I want the value of log base 6 of pi in terms of log base 2 of something. Okay. So that means I want log base 6 of pi in terms of log base 2. So it will become log base 2. Now what is the value of x here?
Pi.
Correct. And similarly log base 2, what is the value of a? A is 6, correct?
Yeah,
So this expression is clear to everyone that how we change the base from 6 to 2, right? Got it?
yeah.
I think this is the same example you will also discuss in the lecture, but it's fine. Okay. So that means that is log base 6 of pi is equals to, now we have some log base 2 of pi upon, but this 6 can be written as 2 into 3, right? So what I will do, I will use the property of multiplication. So this will become log base 2 of 2 plus log base 2 of 3. Okay. Got it? Till now?
Yeah, okay. Okay.
Now, one thing I have to tell, that what is the value of log base a of a?
That would be 1.
1.
Right, 1. Why it is 1? Because we know that a to the power 1 is
A to
equals
the
to
power
1.
1 is A.
Equals to a.
Yeah.
So from here you can get that log base a of a is equals to 1. So that means log base 2 of 2, what will it become? It will become 1. So we got log base 6 of pi is equals to log base 2 of pi. This is will become 1 plus log base 2 of 3. Fine. Till now it is fine.
Yeah.
Okay. Now what we'll do, we'll substitute our values. And so what is 1 by log base 2 of pi plus, what is the value of 1 by log base 6 of pi? So this is the value of log base 6 of pi. I want the value of 1 by log base 6 of pi. So it will become just reverse, right?
1 plus log
Log base 2 of 3 on log base 2 of pi. So now this will become 1 plus log base 2 of 3 into log base 2 of pi. Now here denominators are same, so I can add the upper things. So it will become 2 plus log base 2 of 3 upon log base 2 of pi. Now what will happen? We don't know how to deal with this thing, right? That we don't know what is the value of log base 2 of 3 and what is the value of log base 2 of pi. So still it will remain unsolved, that now what should I do, right? So then what will happen? Using this change of basis property, what we will do, we will define two types of log. Okay. I think you have known. One is called the natural logarithm. Another one is called base 10. So that means any log which has base e. You know what is e? E is?
some constant.
Yeah, some constant which has a value some 2.7 or something, which is an irrational number, right?
Yeah.
And any log which has base 10 is called the base 10 log, obviously. Now, why we always emphasize these two bases? Because what happened in calculus, many of the area equations or many of the regions which have area in terms of e. So that's why we always want this e to be in picture. And similarly, log base 10 is easy to compute. That's why we talk about log base 10. Okay, so these are the general base. Now, by the change of base property, you know that any base you can change into e or 10 using the above property, right?
Yeah.
Yeah. So now this log is denoted by ln, and this log is just denoted by log. So in some textbook, if you see ln, so you just interpret as log base e. And if you won't see any base in the log, you interpret as log base 10. These 2 points you got?
Yes, ma'am.
It is clear?
Yes, sir.
Now what happened here? That still our expression is hard to compute. So in next step, what we will do, we will change this to the ln form. Similarly, this to be base e, and we will compute our things. Okay. So that thing you can do easily. I'll give, because what you have to do, you have to apply the above property here and here also and get your things. Okay. So this will I'll give as an example, as a homework to check it. And this is true. Okay. So just do it. Okay. Just a computation. Nothing more than that.
No, why do you do it as ln? Why can't it be log of to the base 10?
Sorry, what?
Now, why do you want to do it as ln? Convert it to ln.
No,
Why
you
can't
actually in ln it will become simpler. It will
no?
become something which you know. That's
Should
why.
not it be log of 10? I mean log
No,
base
you
10?
can do it in the log of 10 also, but then you have to. Why I'm telling this, because when you use the property, it will reduce to this that ln of. Yeah. So when you use the property of ln, it will reduce to ln of 12 upon ln of pi. That's why I'm
Okay.
telling.
The
And
same thing
it will,
happens. Same thing happens to log 10 also, right? No.
log 10, maybe you get something, some bigger number or some smaller number. I am not sure. But
Okay.
in ln,
No,
you will
ma'am.
reduce
No,
to
ma'am.
this. Yes.
We are getting the log 12 base 2 upon log pi base 2 as well.
Yeah, we are getting this thing, but when you change it to ln, it will become
That's
this
also
similar
yeah,
thing.
yeah,
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 that's
yeah.
why I'm telling. So what happens? So it will become just ln of this is ln of 12 upon ln of 5. So then you can use your calculator to see that it is actually greater than 2. Okay. I mean, this is something which is calculated using the calculator, or
Don't we have it
intentionally you
for log
cannot get.
10? I mean, for log base 10, don't we have it in calculator?
In log base 10 you have, but in log base 10 what will happen now? So many terms will come like this thing.
Oh, okay. Okay.
So it is tough to handle.
All right. Okay.
But in log base 10 also you can do it, okay? So there's
Okay.
no problem. So just take it as a fun exercise. Don't worry about that much. And main point of this property is that you have so many base points, right? Your a will belong to between 0 and 1, and a can be strictly greater than. There are infinitely many points. So if we are able to if we have to define for each base point, there are so many logs, right? So this base property tells us that it is easy to deal with just log base e or log base 10. You don't have to worry about all base points.
Ma'am,
Yes.
after solving that, we got 2 plus ln 3 by ln 5 now, ma'am. But you written
Okay, you have
last
computed
log.
already.
Here we got 2 plus log 3 base 2 by log 5
What
base
you get? ln 2 plus 3 times ln. I guess you got this thing. You can do it. I mean, this is one of the example which also discussed in the lecture. If you won't get, you can also see the lectures. Okay. It's
But
easy.
ma'am, how
Yeah.
how are you
Yeah.
going to explain about this natural and base 10 logarithm? Because I have no idea what
Okay.
what
What
to do
I'm
with this.
saying that when you have log, you have some base, right?
Right.
Now your base has several values. A could be 1 by 2, could be 1 by 4, could be 1000, could be 1
Right.
lakh, or could be anything, right?
Right.
But what this change of base property tell us, no matter what value of A you have, you can always change into some fixed value B, right? Fixed base B. So it turns out in the calculation that this E numbers and this log base 10 is the simplest one to handle. You got my point?
Okay.
That
So
A is
we
equals to
apply the
E.
what we applied above to convert
Above, I'm just telling that,
6 to 2.
yeah,
We have to apply it here again to convert
yeah,
from 2 to E.
yeah. You have to go from 2 to E, so it get more simpler.
Okay. Okay.
Yeah, it get more simpler, and I mean such a simple formula that you can easily calculate using calculator, or intentionally also you can get it is strictly greater than 2 or not.
Okay.
So, ma'am, we have to apply the same rules that you have applied for conversion of log 6 pi.
Yes. Yes, that's what she's saying.
Yeah, same rule, same property, same change of base rule.
Okay, ma'am.
This change of base rule effectively tell us that you don't have to go for all values of base A. It is more than enough if you think about the base E when A is equals to E, or when A is equals to 10. That is the main motive of this expression. Okay. Now everything is clear. Just read once, you'll get the intention that what's going on. And
So,
you guys also haven't seen the lectures till yet, right?
yes, ma'am, we have not seen. At least I have not
Yeah.
seen.
So when you go through lecture, it will be more clear. But in lectures, what happened? There is just 20-minute lecture, so nothing is explicitly defined. That's why I'm recalling it again. Okay.
Yes, ma'am. Ma'am, what are the main topics in this unit?
Main topics is logarithm and graph of logarithm, I guess, properties of logarithm. I mean, this whole week is just based on log, as far as I'm concerned. Yes,
Okay.
the whole unit is based on log. There's nothing. I mean, you have, because log has so many interesting properties, or what I can say, so many useful nature logarithm will intake, because it is because it is an inverse of exponential function. That's why it is so important in mathematics or in any calculus field. You have seen logs everywhere. If you are doing some physical calculation or some mathematical calculation also, you always use log to get something better. Okay.
Yeah,
Ma'am, but what I have seen, ma'am, is that when we are going through the units, like we are in India, right? And when we go for taking the graded assignment, we land in Timbuktu. Completely different, right? Meaning there is no comparison, no relation kind of questions. Unless and until you really spend a week trying to understand what it is
Okay.
completely different.
Okay. So you are telling that activity questions are not related to the lectures. That's
To
your
the
point.
grade, to the graded assignment, right? There's a huge disconnect. I mean, there's a huge gap that we have to fill in ourselves. That's what we are
Yeah.
feeling. At least I am feeling. I haven't
Okay.
been with math for years now, right? So now
So
when
what
I get
happened
into it,
now? So we will try to make graded assignment as tough as we can. So that's the point. Graded assignment are toughest. I mean, you also feel that it is toughest between the activity questions and practice questions also, right?
right,
Yes, I
right.
mean, you are just
yeah,
saying
yeah,
basics, but graded assignment is very difficult.
Yeah. So that's
yeah.
our motive,
Even if
because
the
if we
graded
won't
assignment
put
is yeah,
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 if you won't put difficult question, then it is impossible to solve in the exam also. So that's why graded assignments these
Right, ma'am. But at least in the practice and the activity
okay.
sessions, this question should be a little bit related so that we know that okay, you can ask this kind of question and this is how you go about solving that, right?
Okay, fine.
But the graded questions and activity questions are also out of sync, right? Meaning graded
Yeah,
assignment when we go to it is way out, right? Meaning it is
yeah,
way out of the way.
fine. So
And
I'll
ma'am,
note this point.
exam
Yes.
questions are simpler than graded ones.
yeah, exactly.
The which questions?
That exam questions,
The
that
quiz
quiz one.
Yeah,
question,
so
quiz
that's why
question.
we are put graded assignment tough now. So that if you score 80% in graded assignment, there is, I mean, sorry, not 80, you cannot score 80. I think so. If you score 60% in graded assignment, there is a huge chance that you can score 90% in your exam. So that type of gap we try to maintain. Okay. And for graded assignment, I guess you have time. I mean, for 1 day, 2 day, or how much time
Yeah,
you get?
even 1 week.
Yeah, you get 1 week now. So you have that much time to
Yeah,
think. You don't have to just go through one question and
yeah.
put an answer. Don't kill
We
questions.
have
Okay.
to spend like 1 or 2 day to solve the graded assignment.
Okay. So
In one sitting,
uh,
no one can attend it.
okay, fine. So in 1 week there are 10 videos, right? Hardly there are 10 videos, right?
No, but and
Yeah,
by
yeah,
solving graded assignment, we actually learn.
Yeah, so you learn. Yeah, that's the motive of graded assignment. That's why they are there, so that you can learn and you can score better in your main quiz.
Yes,
So
ma'am. That all makes sense. But see, what I'm saying is, if we practice something in the activity and then it becomes a little tougher than that, then it makes sense, right? But
yeah,
there's no relation, right? Like, until I look at the graded assignment, I don't even know what I'm
Huge
going.
gap.
Yeah,
okay. So there's
what
no.
I'm going to be asked itself is unknown until I go to. So now what I do is first look at the graded assignment and then I say, okay, this is what I need to learn, right? Instead of going through the subject and then going to the graded assignment and saying that okay, this is what I learned, I'm doing it the other way around. I'm looking at the graded assignment first and getting the scare out of myself and saying that okay, whatever is being taught is maybe some portion is covered in the graded assignment, but
Fine,
most
fine.
of it is not, so I have to search somewhere else and learn it.
No, what we think that for graded assignment, first of all, you have so much time. That's the first thing.
yeah.
And second thing, that we should also take care of our exam point of view. That you should not feel that this exam is some out of context.
But
So
what I'm saying, ma'am, is increase the complexity of the
okay,
activity
okay, over
assignment
sure,
as
step by
activity
step.
assignment so that we get to know, we can ask questions based on that, right? Now we
Yeah,
cannot
yeah,
even ask questions on a graded
yeah, yeah,
assignment
yeah.
because it's a graded assignment related question. We cannot even
Yeah.
ask that.
You cannot. Okay, fine. I got your point. So I'll try to make practice assignment much tougher than graded. I mean, similar to graded assignment, so that it will helpful for you.
Right.
Fine. I'll pass
Ma'am, you
this.
can also make graded assignments a little easier than.
No, that this cannot happen. Okay. I mean, you have the whole internet. You can search anything. You have the whole 2-3 days to solve the graded assignment. So just put some work there. And I'm not talking about this only. If you go for any competitive exam now, you will feel like that you will learning something. For example, if suppose you are going for gate, right? So there is calculus, right? In calculus you have learned that you have to find the area using some integral limit or something, right? What they will give some region, they will cut them into 2 and 3 parts, and then they will ask what is the limit. I mean, you are getting my point. They won't ask the direct
Yeah.
question.
Right.
They will use this kind of trick.
Right.
So that's our motive, that our question should be of that level that if you go for any other competitive exam or any toughest interview, you are able to handle it well. That's the main motive. But it's okay, fine. I'll try to make practice assignment as good as graded assignment.
Thank you.
Fine.
Please share this slide or
For some
for today's session.
Okay. So I almost covered logarithm, the domain, range, graph, some properties. There are some leftover things which we'll cover in next session. You guys have any doubt regarding week 5 or till now? We can discuss that.
Ma'am, can we go, if nobody has a question, can we go over some kind of questions that will be asked based on this logarithm so that we can get a feel of what will be asked, right?
Okay, fine. Let's give me one. Mostly you will ask that when the log function is defined, or what is the domain of log function, or you have to solve some equations, or okay, fine, I'll discuss one random
Based
question.
on those properties that we have just
Yeah.
discussed. Okay.
Or okay. So one thing you know, that log function, log base a of x, if your a is between 0 to 1, it is a decreasing function, right? Correct?
Yeah.
By this
Correct.
graph. Okay.
Yes, ma'am.
If you have your base to be strictly greater than 1, it will be an increasing function. Something like this, right? Okay. So now, if I will ask that find the values of x such that log base 10, log base 10, log base 10, and log base 10 of x strictly greater than 0. What will be your answer? It is tough, I know. I mean, it is something you have to. Okay, fine. Before attempting this question, I will give you a hint. Okay. So if you have 10 to the power x, so you know that this is an increasing function, right? Correct?
Yeah.
Yes.
Yeah. Correct.
Yeah. So if I want to ask that 10 to the power x is strictly greater than 10 to the power y, so then what can you say about x and y? How they are
X is
related?
greater than y.
X should be
X is
greater than
greater than
y.
y, right? Same thing happen when you go from log to exponential, or when you work with log. For example, if you know that log base a of x is strictly greater than 0, when your a is between a is strictly greater than 1, then what will happen? This will implies that x is strictly greater than a to the power 0. You got my point?
A log A.
Yeah, got it.
Okay.
Yes, ma'am.
Similar
Because
kind
a
of
to the power.
that means x should strictly greater than 1. Then only your log base a of x will strictly greater than 0. Because
Ma'am,
again, yeah, you won't get. But I'm saying that if you are given that log base a of x is strictly greater than 0, if you have given that your log base a of x is strictly greater than 0 when your a is strictly greater than 1. So that means you have this graph, the subgraph, right? This is the graph of log base a of x, right? I want to find an x. I want to find x such that this is true. This is a well-defined question, right? You can ask, find the value of x such that this expression is true, right? Right?
Yeah, right.
So what happens when a is greater than 0? Your graph is increasing. So you can observe this point. After this point, your log is greater than 0, right? After this thing, your log base a of x is greater than 0, right? After this point,
the function is
right?
greater
Yeah,
Yeah,
yeah.
function is positive, so it is greater than 0. So what is this point?
Yeah.
This point is x is equals to 1, because here what will happen? Our log base a of x is equals to 0, right? At this point,
Yeah.
log is intersecting x-axis, so that means log base a of x is equals to 0. Where? When x is equals to 1, right?
Yeah,
This point
right.
you got? That at x is equals to 1, your log base a of x is equals to 0. And we also know that log base a of 1 is equals to 0, right?
Yeah.
After that, our function is increasing. So so it doesn't matter. So if I'll take x is equals to 2, then also our log base a of 2 is strictly greater than 0, correct? Because 2
Yeah.
is greater than 1 and our log is increasing function. So so that means 2 is greater than 1, and our log is an increasing function. So this will happen, right? Right?
Right.
Yeah. Yeah. Right.
Clear? Similar thing, that if you are of increasing function and your x is less than y, this will imply f of x is less than f of y. Same thing. Here your 1 is strictly less than 2. So it will imply log base a of 1 is strictly less than log base a of 2, right?
Yeah, right.
So that means now this makes sense, that x is should strictly greater than a to the power 0, which is 1. That means x should strictly
Yeah.
greater than 1. Because any other x, for any other x which is strictly greater than 1, this will hold. And why strict? Because I want here strict inequality. I don't want 0. Digestible or not?
Yes, ma'am. So now going back to that question, how is this related?
Now you have some series of log. Okay, so what you will do?
Yeah, we have to apply again and again.
Again and
4
again
times.
and again and again. Correct.
Now
you have this
10 to
thing,
the
right?
power 3.
Yeah.
X must be
So
greater than 10 to the power 3.
just assume this is some t1. So what do you want? We want log base 10 of t1 strictly greater than 0. So what we want? Our t1 should strictly greater than 10 to the power 0, which is 1. Correct? So first condition I will get, my t1 should strictly greater than 1. This line is clear to everyone?
Yeah.
Okay.
And
now
again,
what is your t1? Just apply again. It is log base 10, log base 10, log base 10 of x should strictly greater than 1. Now in place of 0, it is 1. Okay. Now again assume this is your sum t2. Now what will happen? I want log base 10 of t2 should strictly greater than 1. Sorry. Strictly greater than 1. Right? So what does it mean? That
T2 must be greater than
strictly
10.
greater than 10 to the power 1, which is 10.
Yeah.
Now again, that log base 10 of x should strictly greater than 10. So it will imply that log base 10 of x should strictly greater than 10 to the power
It's
10.
fun.
So it will imply x should strictly greater than 10 to the power 10 to the power 10.
Mhm.
Now you got it?
Yeah. So that means these series will open left to right.
Yeah. But observe that here I'm taking 10. 10 means strictly greater than.
Yeah.
If you deal with
Yeah.
a between 0 to 1, the whole inequality
Yeah.
will reverse.
Yeah.
Because in place of increasing, you have decreasing function.
Yeah.
So
Okay.
here you got that what we have used. We have used the concept of increasing and decreasing function. Nothing else. Right?
Okay.
So this
Yeah,
is
it is.
this question makes sense, right?
Yeah.
Okay. So I'm not डरा नहीं रही हूँ बस just that's why I'm saying that you should think that what will happen next. Okay. So you got this question?
Yeah.
Yes, ma'am. Thanks.
Any other doubt, suggestions, feedback, anything? So how's your
No.
course is going so far?
Enjoying the learning,
Yeah,
ma'am.
it is good.
Yes, I know Hindi. If you want to talk in Hindi, it's also fine. Don't worry. Someone asking me. It's going fun. I mean, it's very tough or something. I mean, the score is so low in quiz one also.
But ma'am, what did you say? Like,
Moderate. What?
Sorry, what?
you said something towards the end. I didn't catch that.
I mean, I'm just not making fear of course or questions in your mind by discussing this question. That this question just use the
No, ma'am.
concept of increasing, decreasing function.
Yes, ma'am. That was good actually.
Yeah. So that's what I'm saying.
The course is good, ma'am. But for a working professional like me, I couldn't take 4 subjects, right? Meaning
Okay.
it requires more than the commitment of 10 hours per week, right? If you
Yeah,
really want
that's
to
right.
learn, then it is not going to, even one subject I'm finding it very difficult to cover in 10 hours, right? So going through all the videos, then doing all the activity, and then doing the extra learning to do finish the graded assignment, that is not 10 hours for sure. It is not 10 hours, right? It is
Okay.
taking way more than that.
How many courses you have?
I could take 4, but I took only 1. I dropped all other subjects because I wanted to cover math, because math is something that I really did not like when I was doing my engineering. But
You don't
now
like maths?
I
You are an
wanted to.
engineer?
Yes, ma'am. I'm a
Both
computer science
controversial
engineer, so
statements.
I can understand the
It is
logic.
other way
I can
around.
understand the logic,
Yeah.
but I don't understand. I don't really like the calculus and the complex trigonometric functions, and we
Yeah,
don't
that's
use
the
that.
problem.
We don't use that. Meaning, at least I don't use it in my day-to-day life. That has been years since I have studied that. So now I going back to this thing is little bit tough for me. But that's why I said, okay, let me do math 1, then math 2, then statistics. I would do that way, but I would try to do
Okay.
everything.
Fine. Okay, fine. If anyone want to leave, you can leave. The session is officially end here. We'll just discuss some doubts or some issues if you are facing while you are accessing your content or something else. That's it. Okay. So what you are
Ma'am, can
saying?
you share the PDF?
Yeah, I'll share the PDF.
Ma'am, and when this link available for this session?
Which session?
For this session or yesterday's session, also link or not available right now.
It is not available. It will get uploaded. I will ask them.
Yesterday session also.
Okay, fine. I'll ask.
Ma'am, one more thing.
Yes.
For the non-mathematical background student, it is way tougher than the engineering student field because
Yes,
Okay.
we
ma'am.
are struggling with the even common basic maths calculus. Like so many time, my mind just freeze and I was just thinking कि अब क्या करना है मुझे.
Yes,
So
Yeah, yeah.
this
yes,
kind
but
of
you're
thing
not
I
alone.
feel
You're
so.
not alone in that, right? I am there. I'm an engineer, but I'm with you.
Even
Ma'am,
I'm
I'm
also
also from
working
bio
that.
background.
Yeah, and I feel the same thing.
Oh,
Like even most of the language question also feel like okay, now I understand the language, but I don't know how to convert it in the equations. So most of
okay.
the time, that thing also like feel very difficult to break the uh, each and every question in equations and then solve it. So, can you share something which we can, especially those who are belonging to non-mathematical background, can solve easily, or some other method, you know?
या या आई थिंक एक बारी आप एनसीईआरटी देख लो
Oh,
10 to 12
NCRT.
एनसीईआरटी या
NCRTs are
that will
easily
be
available
more
on
helpful.
internet now. You can access it.
Yeah, yeah,
Yes,
yeah.
ma'am. There
Okay,
is a website,
On the
official
official
website,
website
government.
of NCERT. Yeah.
Yes.
okay, okay.
So आप उसका
You
हिंदी वर्जन एक बार देख लो, वो
Mm-hmm.
बहुत ज्यादा हेल्पफुल रहेगा
Acha.
for
What is
these type of like
NCERT?
analyzing.
Yeah, maths is little
Yeah.
bit tough to handle in first first
या
appearance.
फर्स्ट लुक में बहुत बहुत ज्यादा हार्ड हो जाता है ये चीज़।
I can understand, but you know,
Ma'am,
behind data science, everything is just mathematics and linear algebra. So and statistics. You cannot skip these 3 points. So
Okay.
what I say, just go through NCRTs. If you're still facing the problems, there are tutorial sessions, mentor sessions. You can ask the mentors also, right? They're taking mentor sessions, right?
One more thing happened to me, मैम. जब
Okay.
फॉर्म रिलीज हुए थे फॉर द मेंटर्स, आप मेंटर के लिए आप फॉर्म फिल कर सकते हो, तो उसमें मेरे साथ ये हुआ कि ऑलरेडी मेरे जो सिस्टम में डायरेक्टली एक्सपायर डेट लिखा हो गया कि ये जो फॉर्म फिलिंग का जो टाइम है वो एक्सपायर हो चुका है. तो मैंने सपोर्ट टीम को बहुत से मैसेज किए, मेल किया कि ये प्रॉब्लम और ये इशू है. मेरे पास 15 डेज में जब रिप्लाई आया तो उन्होंने बोला कि अब कुछ चेंज नहीं हो सकता क्योंकि मेजोरिटी लोगों ने कोई इस चीज कंप्लेन नहीं किया है. तो वो भी एक बहुत बड़ा इशू हो गया कि अभी जो करना है खुद को ही करना है, बिकॉज और कोई हेल्प नहीं करेगा.
Oh, you don't have mentors now.
No, ma'am, no mentor.
Okay,
Even
so
I talk to so many, personally message to support team कि at least कोई तो हो जिसके साथ मैं लिंक हो सकूँ या कोई अपने उसमें मुझे ज्वाइन कर ले. बट नहीं हुआ वो भी.
you have sent your email and name to me, na?
या
ओके आई वोंट गारंटी यू दैट ये होगा ही आपके साथ मेंटर सेशन वाला चीज सॉल्व, बट मैं कोशिश करूंगी कि जो भी मेंटर्स है वो एक एक्स्ट्रा स्टूडेंट अपने सेशन में रखवा ले फॉर मैथ में.
या मैम प्लीज.
ट्राई. ओके.
इट विल बी वेरी हेल्पफुल फॉर मी.
ओके. So these
ma'am,
the contents are available on time, right?
या मैम
This
कंटेंट्स आर अवेलेबल, बट बहुत सी चीज़ें ऐसी होती जो समझ में उस टाइम पे नहीं आती. एंड आई डोंट नो टू हुम आई आस्क, किससे ये सारी छोटी छोटी बेसिक चीज़ें उसी टाइम सॉल्व करने की चीज़ें होती है कि कोई आपको थोड़ा सा हिंट दे दे और वो फिर फ्लो में चलता है पूरा, आप जो वीडियो देख रहे हो वो. तो वो बहुत सी बार ऐसा फील होता है कि क्या करें हम.
या करिश्मा मैम, आप एक बार वही एनसीईआरटी का हिंदी वर्जन देख, हिंदी तो मतलब क्लियर
हाँ हाँ,
होगा,
समझ में
लाइक
आ
हिंदी
जाता है.
पढ़ने में तो कोई दिक्कत नहीं होती होगी।
नहीं,
हाँ,
पढ़ने
तो
में,
हिंदी
इंग्लिश
एक
पढ़ने
बार
में
आप
भी.
हिंदी देख लीजिए 10 to 12।
हम्म. ठीक
हाँ,
है.
actually
नहीं, वो ज्यादा क्लियर कर देगा।
that will be more helpful.
ओके.
excuse me, ma'am. Ma'am,
Yes.
actually, I followed the same thing. Like, I did the qualifier and I prepared from the NCRT. Like, मैंने पूरा NCRT से prepare किया था 11th 12th की, तो वो बहुत helpful था. But मैम,
Okay.
अब क्या हो रहा है कि जैसे वीक मैम, like I had another course Python I had. मैम वो कोप अप नहीं हो पाता है कि आप पहले एनसीईआरटी से पढ़ो, फिर उसके बाद आप लेक्चर्स देखो, फिर पूरा वो देखो, तो मैम वो थोड़ा प्रॉब्लमेटिक हो जा रहा है।
टू मच टू डू हो गया नहीं?
यस मैम, क्योंकि 11th 12th में एनसीईआरटी थी नहीं, तो वो पूरा बेसिक से लेक्चर्स देखो एंड दे हैव एक्सरसाइज टू कंप्लीटेड। तो तब तो टाइम था क्वालिफाई के समय, क्योंकि 1 मंथ से पहले से प्रिपरेशन चल रही थी। बट अभी कैसे होगा मैम वो लेक्चर्स?
मेरा
साथ
क्वालिफायर
साथ
मैम
साथ साथ
मैंने
करिए,
वीडियोस के थ्रू
लेक्चर चलता
दिया
रहे
है।
साथ में किताब।
No, it's an issue actually, but we cannot reduce the workload from you, na. I mean, we have to complete these 3 term in a year. So खुद समझ सकते हो कि कितना फास्ट होना चाहिए. But I'll just suggest just
इवन
study, पढ़ो दिन भर.
या
बाकी मैथ्स तो टफ है.
मतलब हमें भी या हमें भी कभी कभी एनसीईआरटी की जरूरत पड़ जाती है, बिकॉज even if I had my MSc like 2 year before,
You had
MSc in
MSc in
mathematics,
mathematics.
in pure mathematics,
From where?
although yeah,
From where?
from University of Allahabad,
Okay, okay, nice.
University of Allahabad.
Yeah.
Okay. So हमें हमें तब भी जरूरत पड़ जाती है कभी कभी, बहुत छोटे छोटे कॉन्सेप्ट थोड़ा सा ऊपर नीचे. And one more thing, one more book, Play with Graph. You
Yeah,
know,
play with graph you can
like
have.
yeah,
Is it available
that
online
that
or?
will be more helpful for the graphing purpose.
Okay.
Yeah, it is helpful for graphing purpose, but again, this book is time taking. I mean, you cannot go from one chapter to, I
Yeah,
mean, it will take 15 days to complete one chapter with the exercises, because I have done it. So that's why I'm saying.
yeah,
But you can have a look to
yeah.
the theory part.
And what was the book? Play with Graph.
Yes, yes.
Play with
So
graph.
it's
Play.
So it is for
Play
only the,
with Graph by Amitabh Agrawal.
Yeah.
so it will be only for the graph chapters, I
Yeah,
think.
Yeah, this is only for graph. Sorry,
yeah,
this is
yeah.
graph. Yeah.
For every purpose, like scaling and everything, everything related
But
to graph.
I guess you just need scaling a little
Function.
bit. वो 4 चीजें ही आपके लिए जरूरी है जो मैंने बताई है. Upward shift, downward shift, and left and right.
Yeah,
You
yeah,
won't. You don't need anything else in this course, as far as I'm concerned.
yes.
And then for calculus, what we should do, right?
For calculus, okay, there is one Thomas calculus.
Just a
You
practice,
can
nothing else.
go through that book also. It is easy to understand.
Thomas.
Thomas calculus by Pearson publication. I think I have PDF. I mean, for non-mathematical background, this course is tough, as I know, and math 2 will be more tougher than this one. But just stay and do your things.
Initially, we
You will
think
get to.
it's just a basic, but as the session goes on, and now it feels like it's very tough.
Yeah. You haven't learned linear algebra, right?
No, ma'am, no idea. I'm just listening each and every topic from this session only.
So then linear algebra vector spaces will take so much time. But it's okay, fine. Just do your work. We will see what we can do. Okay. I'll discuss it,
Okay.
what they will say.
Ma'am, if you don't mind, can you share me your mail ID so as I can personally message in 2-3 days to know the result?
Sorry, you're not audible clearly.
Hello?
Speak aloud. Yeah.
Hello?
She
Yeah.
want your mail ID for help.
Yeah, I want, yeah, so as I can know about the results,
Okay.
quiz 1.
Your quiz one thing. Your name is Karishma, right?
Yes, ma'am. Yes, ma'am.
So I will put my mail ID. I'll send you my mail ID. You can, okay, I'll discuss your issue with Vishnu. Okay, fine. Anything else, or should we leave our session? Any doubt? You want to discuss anything else?
Ma'am, I got disconnected. Have you shared your ID, ma'am?
Yeah, I have shared you. Your name
Don't
is Karishma, na? Karishma.
No, I'm not Karishma. I was asking. I'm Bhumika.
You're what? Bhumika?
Yeah, ma'am. I thought you were sharing to all. That's why I'm asking.
No. I am not sharing you all.
Okay, ma'am. Okay.
Okay, fine.
Ma'am, now you know what is the from POD?
No. I asked my co-worker, they also don't know.
Okay.
So you don't have to worry about. POD means some project, something, I guess.
Ma'am, at what extent calculus will be in
Till
math?
differentiability and area, computation of area volume, those things.
Area means integration.
Yeah, integration. In week 10, no, yeah, in week 9 or 10, you have the whole integration differentiation limit. And then you have some graph theory concept, which are used for data science. So, and then your math one will end on graph theory.
Like completely only integration, ma'am. Aptitude
Difference,
questions will be there.
which question?
Aptitude questions in differentiation.
Aptitude, aptitude questions, you mean what aptitude questions? Usual differential question, the function is differentiable or not.
Equation.
Differential equation.
Hmm.
No, you don't have differential equation.
Yeah, equation.
Ordinary differential equation.
Not
No, you don't need that. Just up to area computation. Okay, so you can leave the session. I'll ask him to this. There is no other doubt. Anyone has doubt? Again, I'm asking.
No, ma'am.
No? Okay.
Ma'am, cubic. What to do with that cubic equation, ma'am? You
Which
said
question?
at last you will tell how to solve for a cubic equation, whether it is 1 1 or no.
Oh, for 1 1 on 2. Okay. So for 1 1 on 2, you have the same.
No. Huh?
No, for 1 1 on. For what?
Yeah, if a cubic polynomial or
Okay. For
more
cubic
than
polynomial, you're asking. Okay. So for polynomial, if they are asking it is 1 1 on 2, so you can use the, you know what is the horizontal line test, right?
yeah.
So for polynomial purpose, if they are asking that it is 1 1 on 2 or not, you will use always the horizontal line test. Because what happened, when you have polynomial, you have zeros and you can easily draw the graph, right? So there, the horizontal line test will help to show the some function is 1 1 or not. Okay. So there you cannot explicitly compute that f of x1 is equals to f of x2. That thing. Okay.
Yeah.
So use horizontal line test in case of polynomials. Okay. Cubic
Um,
polynomial, quadratic polynomial, anything.
that means I have to take some arbitrary values and I
No,
have
no, no.
to plot a graph
Yeah. You have
for
to
that.
first by using the multiplicity and the end behavior and those all things we have discussed in the
Yeah,
polynomial
yeah.
sessions. So you just roughly plot the graph and try to say that there's some horizontal line which will intersect graph more than 1 points. So that will work for proving it is not onto, or it is on. Yeah, it is 1 1 or not.
Okay.
Okay.
Good night, ma'am.